This photo will help test your understanding of the optics of mirrors. The challenge is to look at the images in the mirrors, decide what kind of mirrors they are, and draw ray diagrams that could describe what you see. My advice to you is to first try to draw the ray diagrams from memory. If you need to look up reminders about how to do that, then go ahead and look in the text or another source, and then only then play the rest of the video. If you just decide to play the video without doing the heavy lifting yourself, you won't benefit very much, and also Grandma will be very disappointed. Here's the image again. You can pause it here while you meditate. I think that one of the mirrors is a convex mirror. Even though the crayons have a depth, I've chosen to represent them as just an arrow. The horizontal line across the page is the principal axis. It bisects the mirror. And the virtual focal point is shown to the right of the mirror. Although there are zillions of rays coming from the object and reflecting off the mirror, there are some convenient ones that we draw when we want to find the location of the image. The first ray goes from the object, it runs parallel to the principal axis, and it reflects as if it came from the virtual focus point. The path of the actual light ray I've shown as a solid green line, and the dotted green line is what your brain does when it mentally traces back the reflected ray behind the mirror. Here I add a second convenient ray in blue. This one strikes the mirror at the principal axis, and since at that point the principal axis is perpendicular to the face of the mirror, you can use a handy protractor and measure the angle of incidence of that ray, and that's the same as the angle of reflection. So again, what I've done is drawn the actual light ray in solid color, here blue this time, and I've traced the reflected ray back behind the mirror. And lo and behold, the place where the blue dotted line intersects the green dotted line is where your brain thinks the rays are coming from. And that's the image location, and I've shown the image length, d sub I, below the principal axis there. Even though you only need two of the rays to locate the image, there's a third ray that could be drawn. This one's in red, and it heads toward the virtual focus. Then this ray is basically the reverse of the green ray. This ray heads toward the virtual focus and then reflects parallel to the principal axis. And again, what I've done is I've traced that ray back behind the mirror, and lo and behold, it intersects at the same location as the intersection of the green and blue rays. We know the image is upright because the rays from the top of the object are formed at the top of the image, and we see that it is smaller than the object itself. And since the light rays, once they reflect off the mirror, never actually cross in space, we call this a virtual image, and it's something that we could not project on a screen because the light rays never come together. So it seems to me that the ray diagram I just drew is a good fit for the mirror on the right, because it seems to me that those crayons in the mirror are smaller than the real crayons in the foreground. The crayons on the left mirror are larger, and so we need a different ray diagram for that mirror. If you got that far, you should be very pleased with yourself, almost as pleased as this fellow. The image on the left, I think, has to be made by a concave mirror with the crayons inside the focal length. Here I've shown the object, and the first convenient ray we draw is one that is parallel to the principal axis and then reflects through the focal point. Second convenient ray I've drawn in blue. It's the one that strikes the mirror at the principal axis, and because it strikes at the principal axis, it's very easy to draw the reflected ray going out. And you see that the blue ray and the green ray are diverging in space, so they will not actually come together to form a real image. There is a third ray that can be drawn. This ray appears to come from C, that is the point that's twice the focal length. And the cool thing about C is it's the center of curvature for the entire mirror. So an object or ray that comes along the line from C is essentially normal to the mirror. So it reflects back upon itself. That's why I've drawn a rightward and a leftward arrow on that red line. And then what I did is I took all three of those rays and I traced them back behind the mirror to a point where they intersect. And that is the virtual image location. You can see that it is upright and it's also larger than the object itself. You can even draw a fourth ray. This one I've drawn in orange. This one appears to come along the line from the focal point, and when it reflects off the mirror, it will run parallel to the principal axis. You can trace that ray back as well, and it should intersect the other three. So because the crayons on the left looked larger and upright to me, that's why I thought they should be inside the focal point of a concave mirror. And now here's a question for you and your study partner to ponder. The question is that for that second mirror, I originally drew the object like this, and then I realized that that wasn't going to work out at all. How come?